Okay, what we have here is some factorising of some linear expressions. I've got 6fg minus 28eh plus 8gh minus 21ef. And I'm going to, step one, reorder the terms. I'm going to put them in a different order so that it's easier to factorise. So 6fg minus 21ef. The reason I put the 6 and 21 together is I know they're both divisible by 3. And then I write my plus 8gh minus 28eh, and there I've got the 6 and the 21 and then the 8 and the 28. So I'm looking for a pattern of big and small, small, big numbers. Okay, so on the outside of this bracket I'm going to take my f, and of course the highest common factor is 3, so inside I'll have 2g minus 7e. And on the outside of this bracket here, I'm going to have h, and the highest common factor of these two is 4, so I'm going to have 2g minus 7e again. So there we can see that we've got two factors, 2g minus 7e, 2g minus 7e, that's common to both those terms, so that can come out the front, 2g minus 7e. And in the other bracket, times 3f, so that times that makes that one, and then the 4h plus the 4h, and that's that one done. Okay, more difficult quadratics, factorising again, so we're going to factorise these. The key here is to look for factors of the 12 and the 35. See, this is not a normal quadratic where there's 1 in front of the x squared term, there's an L number here. So the quick way is to look for factors of 12, 1 and 12, 2 and 6, and 3 and 4, and factors of 35 are 1 and 35, 2, 3 and 4, and it goes 5 times 7, and that's it. So I'm going to look for combinations of these and these to fill in my double brackets. So let's think we've got to end up with 43. 3 times 5 is 15, that gives us a 15, and 4 times 7 is 21. 15 and 21 do not make 43. 2 times 5 is 10. 6 times 7 is 42. Getting closer. 7 2s are 14. 5 6 is a 30. Close. Going back to this one, I didn't try 5 4s are 20. 3 7s are 21, that gave me 41. 3 7s are 21, 4 5s are 20, 40, 2 5. So I'm just trying all the options. 1 times 5 is 5, 12 times 7 too big, or 5 60, and 7 no good. And that one, they are going to be 12 and 35. It's not going to make us 43, that makes us 47. And I'm just going to actually refer to my notes on that one. And as in fact, 3 and 4 and 5 and 7, 3 and 4, 3 times the 5 is 15, and 4 times 7 equals 28, and the two of them makes 43, yes it does. So the 4 has to multiply by the 7, so the 7 must be there, and on the outside the 3 has to multiply by the 5, has to be there, and that's it, completely factorised. The next one we've got is 10x squared minus 13x minus 3. So again, we write down the factors of 10 and 1, and 2 and 5. And on this side here we've got 3 and 1. There's not too many to try, but we're trying to make 13, and 30 and 1 no good. Then if we look at the 10 times 1 is 1, and 3 times 3 is 3. Looks like it will work, but it's actually 2 times 1 is 2, 5 times 3 is 15, because we've got a subtraction here. So what we need to do is do 2x, 5x, and 2 times 1, so that would be 1 here, and 3 times 15. It's going to be negative 15 plus the 2 times 1 to give me negative 13.